Great. So hello, everyone. I'm pleased to introduce myself as chapter co-lead of OWASP NYC, along with Guy Osa, and I'm glad to introduce Filipe Pires. Take it away, Filipe.
Okay, thank you, Zoe. Let me share my screen here. Let's start the presentations here. Let me minimize here. Once again, okay. Okay, can you see my screen? Yes, just to be clear if you can see. Okay, can you see my screen? Yes or no?
Yes.
Okay, nice, very nice. It's okay, perfect. So this is during this conversation, first of all, I'd like to present some difference between the SAST and DAST. And after that, I will explain something more theoretical, because the title of this presentation is how you can keep your coding safe during the development process. So nowadays we have this challenge, right? When we talk about how we can develop some software and in a secure way, right? And as I think it's Michael mentioned, so he works with penetration testing, and we have many people working with in this specific area to explore different web applications. And the idea during this conversation is to talk about some difference, and I will execute some demonstration. As you can see here, I'm in my virtual machine, and but first I would like to introduce myself. I forgot that, so this is my. Let me share here my GitHub here. It's Filipe86. I have here some information about me. I'm security research and security advocate. I've been working at Senha Segura. Senha Segura, it's a Brazilian company, but not Brazilian company. It's a global company responsible to provide some PAN solution. It's an acronym of the Privileged Access Management, right? And I'm advocate of this awesome project. Probably you already heard about that. The hacking is not a crime, right? And the idea behind of this awesome project is to explain about the hacking concept and how you can use your creative mind when you're looking for some applications, or how you can using this in a different way. But when you talk about, for example, about the ransomware attacks or the theft of the intellectual property, for example, it's about cyber criminal, not about a hacker. This is the idea behind of this specific project. It's very nice. I'm one of these advocates, and I'm a contributor of the Red Team Village, and I'm a coordinator of the DEFCON groups here in São Paulo. It's a community. The idea is to talk about the security stuff and something like that, right? So just simple information about me. This is my GitHub. You can find here some projects that are being worked in, for example, the threat hunting, some articles published about bar analysis and different topics about that. And you have here my webpage, philipepires.com. It's a simple static webpage. You can find here some information about me and presentation talks in English, Spanish, and Portuguese language. By the way, you have here some talks about different topics, and here other articles if you'd like to read some information on specific topics published in some magazines and so on and so on. Okay, so before to execute the demo, I would like just to clarify the simple topic about what is exactly SAST and DAST. Of course, nowadays we have a different approach using, for example, YAST, using SCA, using REST to analyze the software, or maybe you need to apply the S inside of the famous SDLC. You have a SDLC, software development lifecycle. So how we can put in the secure in front of this SDLC. So that's the idea when you talk about application security or the future about the DevSecOps. Because from my perspective, it's more about the future that you can implementing this in the specifically SDLC, right? The software development lifecycle. So just a simple definition about what is exactly SAST, putting all those people on the same page. So SAST is basically statistical application security testing, and DAST is the dynamic application security test. We have, in this specific case, two different approaches. So when you talk about the SAST, is of security testing that you can implementing this to looking more about the, you can testing your specifically code, its approach. It's more specifically type testing representing the developer approach. So if you are a developer or if you work with the developers, you can using this specifically tools to help you to scanning this specifically code, and you receive some results according the specific tool that I've been using, or you can deliver these specific results to the developers. On the other hand, you have a black box security testing. It's more approach when you talk about the offensive security, or in this case, the explanation is about the hacker approach. Not a hacker, in my opinion, it's just approach when you have the applications published or committed in inside or within your pipeline, okay? Another point is about the SAST requires the source code because you analyze all those codes. In this case, when you talk about the DAST, you doesn't require the source code because you need to have the application published. So it's a different approach, okay? Other point is about vulnerabilities of this SDLC, as I mentioned in the beginning, right? So the idea is to putting the security inside of this specifically cycle. And when you talk about the DAST, you have this information published once again, right? So the vulnerabilities can be discovered after the development cycle. It's very important to clarify. It's two different approaches, okay? And of course, when you have the code, you can use in different libraries. So you can have, for example, a different approach called the SCA, for example, right? And using some, for example, it's kind of about the some libraries to using that, or maybe some third-party libraries that you need to put inside of this specific code, right? And if you have this, you commit this in the end of this life cycle, not life cycle, this specific development cycle, you can use in the approach, okay? Of the difference basically is when you talk about the SAST is less expensive to fix. Why? Because you have this in the beginning of the process. Of course, you have the staging or the test process. You have the QA, the quality assurance, and all those steps is during the development process. But when you talk about the DAST, it's more expensive to fix because maybe you have some critical vulnerabilities. You need to have the time to fix this specific. You need to generate some emergency release to fix this possible vulnerability, right? So just a simple information. This is a reference from Sign Off. It's very nice explanation, okay? And inside of this specifically documentation, I will share this a website for you after this presentation. You have here other different inside of this specifically documentation about ORSEC. ORSEC specifically is an open source tool. You can find this basically this tools inside of the OWASP reference in the SAST tools, right? And here is the same explanation, right? So the SAST approach, basically this tools is based on the idea is about the SAST has a SAST tools, but you have some functions about the SCA, right? So the components, the analysis specifically in the third libraries. And in this case, then I can add the same explanation. You need to publish this in an endpoint. You need to have the URL, publish this to executing something, just to explain the difference. Again, it's a glossary. And another point is the AST is another different approach, right? It's a combination of the both analysis in a statistical way and dynamical way, right? So that you can use it to analyze some codes, okay? Perfect. Just clarify the simple theoretic topic. So let's talk about our main tool, ORSEC, right? So ORSEC is a simple open source tool, and for my opinion, it's not too simple because it's almost a framework. Of course, they put in here in the web page, it's a framework. The idea is to perform some statistical code analysis, right? To identify security flows during the development process, right? And one of this very interesting thing here is they have the support at some language to analyze, like a C#, Java, Kotlin, Python, Ruby. It's more than one language, and they analyze. The tools can analyze the source code in the Terraform and Kubernetes. It's not only program language, right? So you can execute these in different tools, as I mentioned here, like Terraform. And another function very interesting is the idea to you have this option to search for a key leaks or maybe a password or hard-coded password inside of the code, or maybe some private key inside of this specific search code. So it's very interesting. It's not only SAST to looking for a vulnerabilities in code. you have other functions inside of that, and you can using through, for example, in this process of the CI/CD inside of your pipeline to apply the DevSecOps culture, right? And other point, very interesting, you can find the vulnerabilities in, for example, in libraries or in your code or your binary, and you can deliver this information from in some web manager, right? So as you can see here in this specific picture, you can see, for example, how many teams you have, what kind of program language is more vulnerable inside of this project. For example, let's suppose that you have the team A. The team A, you perform, you run the ORSEC inside of that, and you find, for example, more than 100 vulnerabilities in JavaScript. But these teams works with JavaScript or Golang or Ruby, different programming language, but you found many vulnerabilities in specifically JavaScript. So you can look into these specifically results, and you can improve, you can deliver some security training specifically in this programming language. It's very nice because you can deliver, you can improve the knowledge to the developer team, right? So this is very nice. So let me click here in documentation. Before we have here the community, right? You can click here in community, and you have a forum with this specifically tools. You have here others open source tools, but I will talk more about the ORSEC during this conversation. And as you can see here, we have a forum. So if you have any question, you can write here. And Zup Innovation, it's a company responsible for maintaining this specific project. They have an open source team inside of the organization. So they improve a lot their tools, and they have the forum to help the community. It's very, very nice, right? And let's return here. Let me click here in documentations, and let's make do this happen now. One of this very interesting thing here in this platform, how you can see the support language and available tools. Let me explain more details about that. For example, take a look at that. You can find here some engines, right, responsible to detect the code vulnerable, like ORSEC leaks, remember? So if you find some private key inside of the source code, or focus on JavaScript or Kotlin or Kubernetes, and you have another tools, take a look at this inside of this platform. Because of that, it's maybe a framework. Why? Because you have here, for example, for Python, a Bandage project. As you can see, it's another open source, safety, SamGraph. You have here inside of that, take a look at that, OWASP dependency check, very nice, to check the library, right? So an SCCA here, right? And a software composition analysis, as you can see here. So very nice. And Trivi to see more about the code and to see the vulnerability. For example, you can click here, and you can read more information about this specific project, looking more about, in this case, it's more about the analysis inside of it's a container scanner, if I remember correctly, right? It's a container scanner, open source. So as you can see here, it's a framework because you have more than one engine to run and to see the project. For example, if you see sometimes you can find enterprise solutions, or maybe on open source, you have, for example, some specific tools, but these tools just works with the Python and Ruby. And another tool just to work with the JavaScript and Golang. So it's some limitations, right? Because nowadays in our organization, we have many programming language in different projects, right? So how many programming language you have inside of this platform, you can escalate more easily, right? So this is here, as you can see, many different tools and programming language. It's very, very nice, okay? So just a simple overview. Let me return here in the documentation. So how you can work with this specific ORSEC. You can use in ORSEC and web application, as I mentioned. And other very interesting information here, it's the type of the analysis. The SAST, as I mentioned, leaks again to look into the credentials, private key, and hard-coded password, and dependency check, as I mentioned once again. Where you can use the ORSEC locally using a CLI or a CI/CD pipeline, or maybe in an IDE extension. What kind of IDE, Filipe? It basically is VS Code, as you can see here. But I would like to use another specifically IDE. How can I work that? You can suggest, basically, you can suggest to the community to put in another IDE. For now, just supported by the VS Code, okay? So let's go to the CLI here and click here and installations. So we can use in the 4 ways, again, locally, manually, or installations via image Docker and pipeline. So let me click here. It's very simple. I have a Unix platform here, a Linux actually. I will copy this and I have here my virtual machine. I will pass here and I will execute the downloading from the ORSEC, right? Very simple. I will using curl to download in this specific binary, and I have a specifically shell to execute this script. I will request the last version, as you can see here. And if you see, ORSEC is downloaded and move it to the binary to create a specific binary inside of this virtual machine, okay? So I have here now the ORSEC, okay? So I need to understand what kind of command I can use, so I can set basically the help to understand about what kind of commands or flag I can use, right? So take a look at that. In this case, I can set, or in this case, I put it wrong. It's a 2. Yes, help. Now it's correct. Okay. Or sec CLI. Perfect. So I can use in 2 ways, flags and comments. Basically, as you can see here, let's check. I can use it to start, and I can set here -p, for example, to set the project. In this case, P is not a project, it's a path, right? So basically you define the directory. And commands available, I can use in help. I use it help. I can set the start to start a CLI. That here is the next command that I can use. Or version to see the version, or generate to see the configurations, and out completion, completion the script basically. But I will using the just start CLI. Okay. So ORSEC here and start CLI and -- help to see some comments or flags or parameters, whatever name that's the matter in this moment. Okay. So let me return here in the beginning. So I will set here the example ORSEC start, and we have more than one parameters to set here. I just to see some ones here, so a few specifically flags. The first is -a, for example. It means authorization. This authorization, in this case, authorization token, because when you have the web application manager to receive the vulnerabilities inside of this specific web manager, you need to set -a, you need to set the token authorization. You can generate this specific token inside of the web manager, okay? And you using the ORSEC API in this case here to connect in this specific manager, right? Another flag is -p. No, P, yeah, P is a path mention. As it is, I will show you. When I execute this in the specifically directory, in specifically project, I can set this in my own project, or I can set here in another different repository, another different path, right? Another is about -o, for example, it's output format, because maybe you are thinking about the SonarQube, for example, if you work with SonarQube. SonarQube, it's a tool more focused in the code quality, right? And of course, you have a version, enterprise version with some security approach, but you can use both of these tools to help to give the quality code with a SonarQube, and using, for example, ORSEC with more a secure approach, right? And you can set this, for example, -o to send this output to the SonarQube. Very nice. And other comments that you can test after this presentation. So, okay, so I have here, for example, my other folder, ORSEC demo, okay? And what I have here inside of this specific direct, I have some vulnerable codes, as you can see here, in Golang, Java, Kotlin, Node.js, and Python, okay? So if you'd like to test this in your environment, you just to go to my GitHub here, you can click here in ORSEC -demo, and you have here the same vulnerable codes, right? Or if you'd like to test the other codes vulnerable, you can go here in the others. Let me show you here. ORSEC, inside this specifically, you have an ORSEC, the main project, right? ORSEC from Zup Innovation. You have here the, let's check here, where is an example. We have a folder here called example. I think it's here, example. You can click here and you have here more than one others vulnerable codes in different program language. As you can see here, Ruby, Perl, and YAML, Elixir, and ELF. Difference you can test after these presentations. Okay, nice. So are you basically executing the ORSEC starter? We start with, for example, a JavaScript. Okay, so you set here ORSEC start, and I will click enter. And after that, take a look here. It's CLI not found. It's just a simple warning. And take a look this is the folder, right? Because I don't need to set -p because they will pick up specifically this default directory, okay? And after that, I click enter, and I will start the scanning here inside of this specifically directory. As you can see here, this is the project. Scanning code in this moment, and now they will be starting the code. And usually the time to executing this specifically scanning, it's during the 30 seconds or 45 seconds, of course, depend how much or how many lines do you have inside of this specific code. But I am doing the streaming, I am in a virtual machine, so probably you need to wait for, I don't know, 1 minute or 2 minutes to perform the specific scan, okay? So let me return here the documentation during this scanning are happening now, okay? And if you have, for example, a Windows machine, you can download this using curl, or even if you'd like, you can download manually from a specifically executable, as you can see here, Windows 64 or 32 bytes, for example, others Linux distributions, or you have here the Linux different binaries to install, or again, you can use in a different way, or even generate a specifically Docker image, as I mentioned, right? And other possibilities that you can use in here, again, as I mentioned, using a Docker image, you have here all those steps to executing, to have the ORSEC. And as you can see here, basically is the same command, ORSEC start-p to executing this specific directory. And if you want, for example, you can install via pipeline, okay? So in this case, we have here some example, for example, GitHub Actions, AWS Code Build, and Circle CI, maybe is the main CI/CD tools, right? Or in Jenkins, for example, Azure DevOps Pipelines, GitHub, GitLab, CI/CD. So this is the main tools that you can use in here. And by the way, you have here the suggestion of the code, okay? So let me return here. Okay, I finished the scan. Let me return here to see the results, okay? So basically it's finished, it's ended this analysis, and the success, I have the success to executing this specific scanning. And the time here, I think it's almost 2 minutes, as you can see here, okay? Start time and finish time. And let's see about the logs, very important information, the response of this scanning, okay? The first is the language is specifically JavaScript in this case. Let's see here one other information. So I don't know if you have any question, you can write me in the chat, and I can see here if you have some question, for example, or Zoe can interrupt me and ask me if you have some question. Okay, and let's return here. So another point very interesting is about the severity. It's too high. You can see here the specific line that you can find the vulnerability and the column inside of your code. Okay. And one of very interesting thing, in my opinion, it's about the security tools using here in this case, for example. In this case, it's an ORSEC engine. Remember, we have more than one. You have a SandGraph, you have, for example, a Bandit. So you can find here these specifically security tools or engine responsible to detect this code or this specific line has a vulnerable, okay? The confidence in this case is low. The specific file that we found that this vulnerability, as you can see here, take a look at that. Remember, when I execute the scan, this is the main directory, okay? And if you see here, you have more than one director or folder inside this specific project, okay? So, and this here is the specifically code vulnerable that you can find in the log, okay? And you can see here the rule ID from our SAC. So it's our SAC Java, and this is specifically ID of this vulnerability. And other very interesting information, for example, if you are a developer or if you worked with this developer team, you can, for example, suggest the team to understand more about this vulnerability. So basically you can, for example, or click, or you can copy this and open it on the browser to read more information about this specific vulnerability, as you can see here. So this is basically the CWE, right? The common weakness enumeration. And if you see here, this is the main vulnerability about this specifically code, as I show you, okay? And here is the description, and you can see here the very interesting search about how the developer can improve the acknowledgement. Because remember, we are a security guy, and probably we don't have, time to make many different security trainings about the secure development. So how you can give the power of the developer. So this is a way that you can give the power to the developer. You can teach the developer to not only develop the application more safe, but in this way you can deliver more search to find and to understand how you can see the main vulnerability and what kind of parent of this specific vulnerability, or if you have a different approach, for example, as you can see here, explain what is exactly CWE or CWE, or you can explain how OWASP works, what is OWASP top 10, for example. About the OWASP top 10, you have the main vulnerabilities, what kind of other child vulnerabilities you have with the same or with the main vulnerabilities, for example, what different techniques you have for example, cross-site scripting, what is different. So we can have this kind of acknowledgement and the guidance for the developer team. When we give this guidance with the developer team will have the power, to develop more safe the applications, right? So cool. And after that, we have here the type of the vulnerability. Okay, so I perform here in this case in a CLI way. And if, for example, I could set, for example, -p if I want, and I can set here, for example, other directories. For example, I could put in here, for example, let's suppose a root, and I don't know, more analysis and others project, for example, but just to explain. Okay, so another way to executing the RSEC is using an ID, as I mentioned. So you can click here in extension. Basically, you can write here the RSEC, and you have here this specific extension to executing in the ID. So you imagine if you are a developer and you have here the many codes vulnerable here, and you just need to click here and start. And after that, RSEC start the project. So you imagine you are a developer, you are creating your coding in a staging or in a test environment. And after this, you're in the end of the day, you can basically executing the RSEC. And as you can see here, RSEC executing the security analysis running. So something, the scan, it's running in this specific directory, as you can see here. So the tools, it works. So if you see here, the RSEC creates some specifically binary. And if you remember, when I executing this here, they create here a specifically file, doc.rsec. Is a kind of, not a backup folder, but it's just a simple folder file to creating automatically and remove it after this scanning, right? So it's happened the same way when you talk about this specifically IDE, right? And as you can see here, the scanning are running, as you can see. And here I run executing in this all those specific code in Golang, Java, Kotlin, Node.js, Python, and PHP and Python. Okay, so let me see another very interesting for I present you. So after this in ID, I will execute this in my pipeline. So I will simulate here, for example, let me return here, how you can improve this or how you can using this specific tool in your pipeline, for example. Let's suppose you can use an autosec, for example, in the stage or in the test environment, or you can put in this, for example, as a gate, right? In your CI/CD, for example. Let me go to my specifically folder here. Let's go to the autosec demo folder. I will click here. So let's see here in my GitHub Actions, and I don't have any workflow running here, as you can see. Basically, to set this, I need to set up some workflow, right? So some job. So here is the suggestion, right? So basically how you can create that. Basically, you need to create a GitHub folder and workflows and create some EML to execute in this specifically flow to simulate a specific pipeline, right? So I will create that after this scanning running here, okay? So now I finished here, as you can see. Take a look at that. Our SEC is finished with the success, and we found 10 vulnerabilities, or actually 10 vulnerabilities were found, right? So let me return here. Let's go to the specific vulnerability. Let me click here, and I have here the simple vulnerabilities to see. So as you can see, this is one of those vulnerabilities, right? So let's check here. Not here, yeah, it's here or not. Let's check where is the vulnerability. Yeah, it's here. No, sorry for that. It's here in the log. Oops, sorry. Okay, yeah, it's correct. Let me turn here. Here it's the vulnerability that you define here. It's in this case, here is the vulnerability. I will click here, and if you see, this is basically it's old cryptography, right? So MD5, it's not recommended from the security in this case. And for example, here using, let's check here in Python, for example. As you can see here, let me close this. I just put in the mouse here, and you will see the specifically explanation about this vulnerability, right? About the leaks, for example. In this case, as you can see here, the password is hard coded here, right? So we need to change this, or you can set, for example, some not vulnerable. You can set some a different. You can use it, for example, a vault to setting some tokens, or not token, but you can use in some environment variable, for example. You can change in that, not putting in the hard-coded password, as you can see here, okay? And here is the explanation of what is exactly hard-coded password and what is exactly the vulnerability, as you can see here, right? As you can see here, it's another CVE reference. You have here the 7980. It's another reference about specifically this vulnerability, as you can see, right? And let's check, for example, other vulnerabilities here. In this case, JavaScript in injection, for example, file, and this specific file. If I put here, it's a JavaScript or sec using a shell interpreter when executing in a OS commands, as you can see here. And once again, the reference of this specifically vulnerability. So we see here that we have more than one vulnerability in this specific project, and a different CVE ID to see, not CVE ID, CWE, to see the specifically explanation about this vulnerability, that you can improve that. You see exactly the line of this specific vulnerability that you can work about that, how you can improve this specific code. And as we can see, different program language, right? So different engines, different program language, and different vulnerabilities that we can improve. So again, I show you in the CLI mode, and another option is about the IDE, right? Using VS Code, okay? And the last, we can use in here, for example, creating a specifically file here. So let's check here. Let me close all those things here. And I have here my GitHub workflow, but I need to generate, remember, some EML file. I will create here the orsec EML, and I will return here in my project. Let's see here the suggestion, and I will copy this. And basically I will pass here, let's see here, and I will delete this specific line because they changing that the last week, I think, and I have some problem in the last presentation that I made. Okay, so this is the name of the job basically, and I will call security pipeline. Again, I will simulate specifically idea about my CI/CD has a gate. For example, let's suppose that you have a production environment or maybe a staging or a test environment, and you putting this specific job to executing before the commit you provided from the developer. And this is the specific job. So the developer needs to executing this specific curl. Remember, it's the same curl that I'm executing via CLI. And after that, they will execute the orsec start -p exactly in the folder, right? And I will set here -e, in this case called true. Basically, if the orsec find some or any vulnerabilities inside of this specific directory, I will receive the error 1. It means that we have some vulnerabilities, okay? And if have some vulnerabilities, I will broken the pipeline, and I will, receive some message, and I can talk with the developer to improve the code, okay? So perfect. So let me return here in my GitHub Actions. As you can see here, let's see if I have any jobs here. No jobs running here. Let me return here. It's okay. That's okay. Let me go through this orsec here. Let's check. Okay. Return once again here. I think I need to go to orsec demo. Let's see here. Okay, GitHub stats. If it works good. Okay. Okay, so I need to add the new file. Git commit -m, and I will call orsec demo. Let's see here. Okay. That's correct, because I create this specific file, and I will push for my original master in this case, okay? Okay, so now cross your fingers and let's see what happened. I always forgot my password. Let's check here. Yeah. Okay, I can set, for example, git pull. Because I need to update that. Or I have, let's put in here, force. Because just a simple demo, okay, and force it updated. Very nice. So let me click here in actions and take a look at that security pipeline. It's running. So it's running now this specifically job, right? Remember, let's suppose this is my CI, and I will executing this in my pipeline. And if I found some vulnerabilities, I need to broke. It's a gateway, okay? It's a gate, not gate. It's a gate of this specific project. And as we saw, actually, this is a vulnerable code. So I need to broke this specifically code because it's vulnerable, okay? So it's in progress now, and let's see what happened specific. Let me click here in orsec, take a look at that. So the job is set here, as we can see, right? Creating this basically the virtual environment. And after that, they will check the code, as you can see here, to see the repository, and starting scanning code. And in the end of this specifically, take a look what happened here. The next, to executing the orsec security, we need to run this curl I don't know if you can see here, but let me show you here. The same curl that I executing, the bash, right? I download the binary, and after that, I move the binary, as you can see here. And after that, starting the scanning. And after that, executing the scanning, as you can see here. And let's go to the end. It's called scanning code. And if you see here, the same log that you're executing in a CLI, right? In this case, it's almost 1 minute. And as you can see here, the results is almost the same. But in the end of this log, as you can see here, take a look at that, it's very interesting. For example, in Golang, in Golang, in this case, the security tools is some grep, as I mentioned. Remember, you have different tools. In this case, it's some grep. It's very nice. In Python, for example, you have a bandit, okay? And let me go to the end of this. Or here is another. In GoSec, you can see here, it's a GoSec security tools in more than one tool from the same program language. And let me go to the end. So we found 12 possible vulnerabilities, 5 medium, 4 low, 1 criticals, and 2 specifically high, right? And we received the error code 1. Remember, I set the flag -A. So if I have here in this specifically code -1, not dash, but with this specifically as it code 1, it means this code is vulnerable. So I can't publish this specifically codes or you know, finish this specifically pipeline. Okay, and yes, this is the idea during this conversation. And let's see here. Let me finish here my Zoom session and interrupt my sharing. Yes, that's the idea. Now I'm seeing the chat, and let's see if you have some questions. Okay, and let's see here. The Brooke must for SecScan is the entire source code graph in order to perform its analysis. Yeah, the idea behind of the SecRook is to executing in the complete source code, right?
So the reason I asked